Okay, for the 9.2 homework, we're going to start off with number 27. And 27 direction says find a formula for a sub n for the arithmetic sequence. So we're looking for the alternative form of the arithmetic sequence, which is a sub n, a sub 1 plus n minus 1 times d. So analogous to linear equation, where in a linear equation you need a point and a slope in order to find slope-intercept form. For an arithmetic sequence, we need enough information to be able to find a sub 1, which is our first term, in d. Well, we already have a sub 1, and then our goal is also to find d. So note we already have a sub 1, so we know that's 5. Now if we didn't have a sub 1, we'll talk about what we would do. But to find d, that's the common difference, which is, since an arithmetic sequence is linear growth, because the definition of a arithmetic sequence is a common difference, meaning the increase or decrease from one term to the next is the same, which makes it linear. So we do the same d, finding d. If you're given two terms in the arithmetic sequence, you can simply do the slope, the change 15 minus 5 over 4 minus 1. That's how much the values change per term, which would be 10 over 3. So we have n minus 1 times 10 over 3, put that in parentheses, and we could simplify that by distributing the 10 thirds and so on. The answer for the book does give us a like a linear equation or a linear form of it, but that will work for us right there. Now let's say we didn't have a sub 1, what you would, and let's say it was like a sub 2 or a sub 3, then what you would do is, you wouldn't have this 5 right here, you have an a sub 1, and then you could take either of these and substitute the n in for that and the a sub n value in for that and solve for a sub 1, and then you just rewrite. For 41, they give us the arithmetic sequence in recursive form, where a term is based on the previous. So if we look here, what the saying is a sub k plus 1, whatever term that is, the term before it, which would be a sub k, because k plus 1 minus 1 would be the term before it, which 1 plus minus 1 is 0, so just k, so a sub k. We subtract 10 from the previous term. So this is our common difference, and as we know from the recursive form, is a sub n equals a sub n minus 1 plus d. So if we want to find the next term, a sub 2, that's going to be equal to the term before, which is a sub 1 minus 10. I'm sorry, my writing with the stylus is not that easy right now on my iPad, so sorry for poor handwriting skills at times. So if a sub 1 is 200, then a sub 2 is going to be 10 less than that, is 190, and then you simply continue on the same. A sub 3 equals a sub 2, which is 190 minus 10, and that would then give us 180, and then we can continue on for the a sub 4 and a sub 5. So for number 61, they asked for the partial sum for n equals 10. That means for the first 10 terms, find the sum. So we can go to our s sub n formula. We have two s sub n formulas, which is n over 2 a sub 1 plus a sub n. The other one, in terms of a sub 1 and the difference, is 2 a sub 1 plus n minus 1 times d. I should have used brackets for those outside parentheses. So both of these do the exact same thing in terms of finding the sum through whatever term, the partial sum through whatever term we're talking about. I know it's called a partial sum because it's stopping the arithmetic sequence at a particular value. If we went on to infinity, that would be the infinite sum, which in arithmetic sequences isn't going to do anything for us. It's either going to be positive or negative infinity. But we'll talk about other infinite sums that come to specific values as we move forward, a finite value. But for arithmetic sequences, we got to figure out which one of these will work in this case. Well, I have the first term, so I have a sub 1, which is great. I also know what the difference is. The difference is -3 because we're going down by 3, so I'll go ahead and write that. So if I have d equals -3, just to make a note here, which one would be more beneficial? Well, if I look at this one, I need the first term and I need the last term. Well, I could find the last term, but why do work if I don't need to? Because in the second one here, I have a sub 1 and d. So I'm going to use the second one. We're finding the sum through the 10th term, so n is going to equal 10, so I simply plug 10 in for n. I know a sub 1 is our first term, which is 40, plus, this is n minus 1, well, n is 10, so n minus 1, if I plug in 10, will go to 9. The difference is -3, so I plug in -3, and now I simplify. 5, and this would be 80 minus 27, and that will get us 265. For 73, it says find the partial sum of 2n minus 1 from 1 to 400. That is a lot of work if we plugged in 1, then plugged in 2 all the way up to 400. So there's got to be a different technique here. And there is. So if we look at 2n minus 1, that's an arithmetic sequence. So what they're asking for is the sum of an arithmetic sequence, which is an arithmetic series. We have formulas for that. We know s sub n equals n over 2 a sub 1 plus a sub n, or the second one, which we introduced, at least within this video I introduced in, I think it was the last problem. So we could use either one of these if we know the first term, or we could use this one if we know the first term and we know the last term. We could also use the other one if we know the first term and the difference. So in fact, in this problem, I think it'd be beneficial to use either of them. Either of them are fairly easy to get. So for instance, a sub 1 would be plugging in 1 in for here and then figuring out our output. If we do that, we plug in 1, we get out 1. And then our last term is the 400th term, which is 2 times 400 minus 1, which is 800 minus 1, which is 799. Note, we've talked about in class, 2n minus 1 is odd numbers, so we're asking what's the sum of the first 400 odd numbers. And note, now we have a sub 1 and a sub n, so we can now go ahead and find s sub 400. And note, how do I know there's 400 terms? Well, it's fairly obvious in this case that we have 1 to 100 or 400, but note 1 is included in that. So let's say if I went from like 29 to 50, I want to know how many numbers there are. Well, the difference of that is 31. But it also includes 29, so the answer is 32 in terms of how many numbers. So the way that we calculate how many numbers, we subtract them and then we add 1. If we did the same here, 400 minus 1 plus 1 gives us 400, and that's how we know that's s sub 400. So we're going to plug 400 in for n, divide by 2, clean that up, there we go. A sub 1 is 1 plus a sub n is 799, and then we go ahead and simplify. That'd be 200. 100 plus 799 is 800. To do a calculation like this, just a quick note on multiplication, when you have, tens, hundreds, digits multiplied by each other, you just do 2 times 6, and then you add the zeros. There's 4 zeros, so you put down 4 zeros. 1, 2, 3, 4. 160,000 is your answer. So the next problem we're going to look at is 83. I took a picture of the teacher edition, so you already have the answer. It's 2340. How do we get there? Well, it says determine the seating capacity of an auditorium with 30 rows of seats in which 20 seats in the first row, 24 in the second, 28 in the third, and so on. So if you look there, we have to make sure this is arithmetic. Obviously it is because we're in the arithmetic section, but as you move forward, you're going to be asked this question on a review or a test where it's going to be intertwined with geometric or some other non-arithmetic or geometric sequence series. So you have to make sure we're okay with determining that it is arithmetic. And so if we look here from row 1, which is 20, row 2 is 24. If I do 24 minus 20, that would be 4. And then 28 minus 24 is 4. And so on means it's going to continue in this fashion. This tells us that it is arithmetic because they have a common difference. A sub 1 is going to be 20 because in the first row we have 20, and then we have a common difference of positive 4, 24 minus 4, 28 minus 4. And so if we have 30 rows, we want to find the seating capacity, meaning we want to sum them all up. That means we want to have S sub 30. Well, we have our two formulas like we talked about before. I think given that it was quite easy to find A sub 1 and D, we're going to use the second of those, which would be N over 2, and N is 30 in this case, bracket 2 times A sub 1, which is 20, plus N minus 1. N minus 1 would be 30 minus 1, which I could simply write as 29, times D, which is 4, and we go ahead and simplify. 15, this would be 40, that would be 120 minus, let's see, 120 minus 4, which is 126. Just a quick mental note on how mental multiplication. I decided to turn this into 30. 30 times 4 is 120, but there's one, since it's 29 fours, it's one less than 120. So 120 minus 4 should give us not 126. Of course, fallible human being, that should be 116. So now we have 15. Whoops, halfway was going to write a bracket, then decided to write a parenthesis and got that squiggly nonsense. And so now we get 156 when we add those together. And then 15 times 156 gives us our answer of 2,340 for S sub 30.